Hi boys and girls. Today's video is the review for the Module 1 test. All right, this is your first module test, so this is kind of a big deal. And I've prepared sample problems from McGraw-Hill that are very similar to the questions that are on the test. So if you watch this video, you will be in a much better position to pass the test. You can also watch it while you're taking the test if you want. That might be helpful too. I don't know. It's up to you. There is a secret word embedded in today's review. All right, so let's get started. Way back in the beginning, when we first started Zooming our classes, we were writing numbers with exponents, okay? They just want you to be able to take 2/3 times 2/3 times 2/3. You know that that's 2/3 to the 4th power, okay? So let me put this on pen. There we go, okay. So when we're looking at this, we just count. How many of these are there? 1, 2, 3, 4. So we're looking at 2/3 to the 4th power. It's going to be one of these two. But how many 5s are there? 1, 2, 3, 4, 5. There are 5 of those. So the correct answer is C, because there are 4 2/3 and 5 -5s. Memory lane. All right, and then they had you do it with variables, okay? You just have to count up how many there are. Here, we start with A's. We always go alphabetical order. A's, we have 1, 2, 3, 4, 5 A's. So it's going to be one of these two middle ones. How many B's are there? 1, 2, 3, 4, 5, 6, 7 B's. So the answer is B. Here's another example. Count up the A's. 1, 2, 3, 4, 5 A's. So it's going to be B or C. How many B's are there? 1, 2, 3 B, 4 B's. There's a fourth one. So we're looking for A to the 5th, B to the 4th, which means the correct answer here is C. Here, this was multiplication of product of a power property, which I will not miss saying, believe me. What we would do here is we would reorganize this, okay? This is really -2 times A times 3 times A to the 4th. All of those numbers were being multiplied with each other. We also, according to the commutative property, can rearrange these numbers. -2 times 3 times A to the 4th. Well, -2 times 3 is -6, and A to the, what's the exponent on here? If it doesn't have an exponent, it's a 1. So this would be A to the 1 plus 4. Remember, when we multiply two numbers with like bases, we add the exponents. 1 plus 4 is 5. So we're looking for -6, A to the 5th power. Right here. D's the winner. All right, the table shows the seating capacity of two different facilities. About how many times as great is the capacity of Madison Square Garden in New York City than a typical movie theater? This is a question that is very similar to an air question. They want to know how many times is big, all right? And whenever you do how many times is big, you always take the larger number, which would be 3 to the 9th power, and divide it by the smaller number, which would be 3 to the 5th power. Right? Remember that this is the quotient of powers property. So this is equal to 3 to the 9 minus 5, which is equal to 3 to the 4th power. So then we come over here and we see that two of the answers say 3 to the 4th. Well, what we need to know is what's 3 to the 4th equal to? Well, 3 to the 4th power looks like this. And 3 times 3 is 9. And 3 times 3 is 9, and 9 times 9 is 81. So the correct answer to this one was B. Now here we have a quotient of powers property. When we were faced with a problem like this, what we did was we broke it up into smaller fractions. 2 to the 2nd over 2 times 3 to the 3rd over 3 times 4 to the 5th over 4 to the 4th. Right? Then we used the quotient of powers property. We did the top exponent minus the bottom. Remember, if a number doesn't have an exponent, it's a 1. So this was 2 to the 2 minus 1 power times 3 to the 3 minus 1 power times 4 to the 5 minus 4 power. Well, 2 minus 1 is 1, so we have just a plain old 2, or 2 to the first power, which we don't write. 3 minus 1 is 2, so this would be 3 to the second power. And 5 minus 4 is 1, so this is just going to be a plain old 4. So we go over here and see which one of these matches. It looks like A is winner, winner, chicken dinner. Be careful because B has 3 to the third power, and that's not right. But it looks a lot like it. Okay, now we have Bolivia has a population of 10 to the 7th. All right, so we're going to say Bolivia, 10 to the 7th. Aruba is 10 to the 5th. Okay. The Philippines has a population that is 10 to the 3rd times greater than Aruba. Okay, so the Philippines, abbreviated Philip, is 10 to the 3rd times greater than Aruba, which was 10 to the 5th. Okay, so this is going to be 10 to the 3 plus 5, product of powers property, which is 10 to the 8th. Okay. So which statement is true about the population of the 3 countries? Well, the first one says Aruba has the least. And that first one is true. Aruba does have the least. 10 to the 5th is the smallest number. Bolivia has the greatest. That's not true. The Philippines is greater. The Philippines has the least. No, in fact, the Philippines has the most. And Bolivia and the Philippines have the same. Nope, that's not true either. So A was the only correct answer. Okay, now we're raising a power to a power. All right, when we did this, we remembered that we had to distribute this exponent to everything in the parentheses. So this is equal to 7 to the 1 times 3. And then we have W to the 7 times 3. Remember, when we raise a power to a power, we multiply the exponents. Well, 1 times 3 is 3, so this is 7 to the 3rd power. And then we have W to the 7 times 3 is 21. But we'll notice that they don't have a 7 to the 3rd. We need to know what 7 to the 3rd is equal to. We're going to need a calculator. I can do some things in my head, but some things, I know my limits. Not doing 7 to the 3rd power. I know it's one of those bottom two, but I can never remember which one. Okay, it's 343. So this is 343 W to the 21st, which is option D. Are you having fun yet? And there we have our secret word. The secret word for today's video is frog. Don't sign off because this is where it gets good now, okay? Simplify the expression. All right, here what we have is we're going to take this 3 and we're going to distribute it to every item in the parenthesis. So we're going to have -5, and yes, it will be in parentheses, but it's not going to matter in the end because this is an odd exponent, to the 3rd power. And then we're going to have W to the 2 times 3. Remember, when we raise a power to a power, we multiply the exponents. So we're going to have 1 times 3 here. And then we're going to have Z to the 8 times 3. Well, -5 to the 3rd power is -5 times -5 times -5. Well, 2 -5's multiplied together is +25. But when you multiply that times the 3rd -5, you get -125. So right away we know it's got to have to be either A or B. But what do we get for W and Z? Well, W to the 2 times 3 is W to the 6. And Z to the 8 times 3 is Z to the 24th. So then we go back over to our choices and say, okay, which one's going to be correct here? They thought you would add the exponents, but you know better. When you raise a power to a power, that's when you multiply the exponents. So don't get tricked by that first one. The correct answer is B. Okay. And when a calculator gives you an exponent, okay, when the calculator gives you this, what this is 2.4 times 10 to the negative 3 power, okay? E says this is your exponent, okay? Now, they want to know which of these is equal to this. Well, do we see this anywhere here? I see this one. So that's correct. But what about those other ones? We need to take this out of scientific notation and see if there's another correct answer. So we would have 2.4. The negative 3 says move the decimal 3 places to the left. 1, 2, 3. We fill in dippies with zeros and we get 0.0024. Do you see that over here? I do, right there. All right. The other ones are not correct. The only two correct ones are this one. This is in proper scientific notation form, and this one's in standard form. Here we have another question. Which expression represents w to the negative 7 times w to the third written in simplest form? Well, let's think about this. W to the negative 7 plus 3. Now, we're not doing a power to a power anymore. This is the product property, and so we add the exponents. When we did the product means you're multiplying two numbers together. You add the exponents. Okay, so we're going to add negative 7 and 3, which is going to give us w to the negative 4. But we can't, this is not simplest form. You can't have a negative exponent and have simplest form. And remember, the way we fixed that was we put a 1 over it and we dropped w to the 4 to the denominator, and this is the simplest form. So the correct answer was A. Fun times. All right, which expression represents that number in scientific notation? Okay, well, the decimal begins here, all right? The non-zero numbers are here, 8, 7, 8, 5. We are only allowed to have one number to the left of the decimal, so the decimal goes there. This is an extremely large number, so right away we can eliminate C because it has a negative exponent, and negative exponents are very small numbers, so C is not right. How many places does the decimal move? If it starts here and it ends here, how many places did it move? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So this would be 10 to the 9th power, all right? And that means that the correct answer was A. All right, which of these is this number in scientific notation? Well, we have 0.524. In order to be in scientific notation, we need one number to be one number to be to the left of the decimal. So this decimal is going to have to move from here to here because we want to have 5.24. All right. Now, because this number is a very small number, we are going to have a negative exponent. How many places did we move it? Just one. Right. So the correct answer was C. Good times. I know, I love it. Alrighty, so now we have the dime problem, and we've done this one in class. A dime is 1.35 times 10 to the negative 3 meters thick. What would be the height in meters of a stack of 1 million dimes? Okay, so this is a multiplication problem. We have 1.35 times 10 to the negative 3, and we're going to multiply that with 1 million. But we need 1 million in scientific notation. So let's write out 1 million. There we have a million. How would we write it in scientific notation? It would be 1 times 10 to the what? Well, the decimal starts here and it has to end here. How many places does it move? 1, 2, 3, 4, 5, 6 places, and it's a large number, so it's a positive 6. So we have 1 times 10 to the 6th power. Okay? Now, because this is just all multiplication, and multiplication is commutative, that means you can rearrange these terms. I'm going to rearrange them so that the regular numbers are next to each other, and that the powers of 10 are next to each other. 10 to the 6th. Okay, so this is 1.35 times 1. 1.35 times 1 is 1.35. And then we use the power of a product property to know that when we multiply two numbers with like bases, we add the exponents. So we're going to add 10 to the negative 3 plus 6, which is 10 to the third power. Okay, and so then we come over here and find that indeed B is our correct answer. It's awesome, right? Well, that is the end of your test review. Feel free to watch this more than once. And like I said, feel free to have it on while you're taking the test too. It might be helpful. Okay? You guys are going to do great. And if you have any questions, you know where to get in touch with me. In the meantime, take your secret word over to McGraw-Hill and answer the secret word question. Have a great one.